this little Geogebra vid is going to be about circles, because circles are cool. So let's have a new one, and we won't save any of that. And using Geogebra, there's a number of ways that we can make a circle. So the first way is using that one, but look at the drop down. We can have a circle with a center through a point, we can have a circle, center and radius, we can have a compasses, we can have a circle through 3 points, and then we've got semicircles, circular arcs, semicircular, circumcircular arc, circular sector, circumcircular sector. So lots of different types of circles and bits of circles that we can have. I just want to focus on circle with center through a point, I think, to begin with. There's another way we can do it, which is to have an input, and we can have a command which is circle. And when we put a command like this in, it allows us to select how we're going to do it. But sometimes we need various bits already. So let's have a point, and we'll put a point A, and we'll put another point B which we can change, and we'll say circle, and if we just go back and not quite write the word circle, it'll give us those options again, and I'm going to have circle, point, point. So circle, so now I've got to put in that I want it to go from point A, and if I use the right arrow on my little keyboard, and I just right arrow, so it automatically highlights that one. Otherwise, it takes quite a faff to get rid of all that and put it in, select the right bit. So now I've got circle AB. If I enter that, it will keep it. And what that has done is say, right, I've got circle center at A, and the radius is B. So I can change where B is. But because I put B on the x-axis, I'm restricted to B being a value on the x-axis, but that's okay because B just represents the radius of my circle. So let's have a circle radius 5 center origin. We could have a different one. So because I put a point on the origin, and you saw, let's do it again. Let's have 2 more points. So let's just turn that circle off and turn those points off. Let's put another point anywhere and another point anywhere, and we'll have circle. And we'll do the same thing again, circle, point, point, and we'll have center as C, and right arrow, and it must go through point B. And now, because I didn't put C or D onto the axes or the origin, to move things around, we need to be on the move key. Yeah, so select the arrow when we want to move or enlarge things. So C will change the center of my circle, and it automatically wants to go when I'm close to a whole number, an integer value coordinate, it jumps to it. It kind of wants to go to whole integers, and we'll have a radius of, so I don't know why hasn't it gone to D. Let's get rid of that circle so we can delete. I want it to so circle, point, point, start at C and join it to D. Right, that's good. Right, so what's happening when I move C? Is it still going through D? Yeah, that's better. And as I move D, right, so we've got circle, center -4, 2, and we'll have a radius of 6. How's that? Yeah, because I've got 6 squares, 1, 2, 3, 4, 5, 6 away from my center. And look at it, puts the equation of the circle in for us. Hey, circle center through D with center C. That's how I set it up. I put C and D in the right places. So I've got center -4, +2, and a radius of the square root of 36. And we can probably change how that equation looks. Yeah, equation look. So that's when, if we get presented with that equation, we could enter the circle equation in that way, and then we could change the equation and put it into x minus a all squared plus y minus b all squared equals r squared, rather than completing the square, as we should know what to do. Right, so why are we looking at circle, Steph? Well, because there's a few things we can do, and this button gives us lots of different types of lines. Look, aren't they good? We can have parallel lines, perpendiculars, perpendicular bisectors, angle bisectors, tangents. So if we put a tangent, and we put a tangent to the circle at D, sorry, tangent, yeah? Right, it says, so I've got, if I highlight tangent, I have to, if you hold it there, it tells you what you have to do, look. So select point or line, and then circle, conic, or function. So we've got a circle, so we've got to select our line, our point first, D, and then we've got to click on our circle, and D, and it puts the tangent of the circle in there. So as I move D, so I'm going to change the size of my circle, but look what happens to the tangent. Yeah, it stays with D, look. So I'm moving D around, and as I do that, so does my tangent move around. Awesome. What about this one? I want a perpendicular line. And what does it say about perpendicular line? Select point and perpendicular line. So perpendicular line to D, sorry, perpendicular to D, perpendicular to the line, and it goes through the center of the circle. Look. Oh, I wonder why. And as I move D, so I go back to the arrow, as I move D, so I move, change the size of my circle, but I'm moving, my tangent to the circle is still at D, and I've still got a radius from C to D that is perpendicular to my tangent. That's good, isn't it? I can also, if I put another point somewhere, I could do E and say, okay, tangent from E to my circle. Oh look, there's two of them. And what do we know about tangents to a circle? Well, if we highlight, first of all, the point of intersection of tangent and circle, and we do a segment is a part of a line, it tells us that that length is 11.58, and it's labelled it J, not H, J. So to undo something, Control Z, or we can edit and undo. And if you undo something and you didn't want to undo it, you can redo it. So if I redo that point, look, it comes back on. I didn't want it, so undo it, get rid of it. And if I have another line segment going from E to G, look, it's the same length. It's called it segment K. I just wanted to change the position of J and put it on the outside just to highlight that that segment was J and this one is K. And the segment, which is the distance from E to F, is the same as the distance from E to G. Isn't that good? Oh, Steph, you mean we can use segment to find distance between 2 points? Yeah, isn't that good? So there's some just playing with where we put the point, and look, we've always got that thing. And what we can do next is make another segment, for example, and go from F to C, and we can have an angle which measures the angle, and if I highlight line and line, then it shows, oh, it's a right angle. Oh, Steph, the angle between a radius and a tangent is 90. Is that true every time? Yes, I should think so. Happy? Yeah, just some things to play around with the circle. Right, what if we want a... No, that's all for now, I think. Just to show you a few things that are going on there. Yeah, that'll do. Oh, let's have a chord. Let's choose 2 points on the circle. So if we put a new point and we put it on the circle, then when I try and move the point H, because I put it on the circle to begin with, it stays on the circle. I can only move H around the circle. Let's put another point on there, also on the circle, and if I have a segment between H and I, we know that's called a chord, and we can do a couple of things with that segment. What I wanted to do was to find the perpendicular bisector of the segment. So perpendicular bisector, what does it tell us to do? Select 2 points or one segment. So there's our segment, and it perpendicularly bisects it. Alternatively, I didn't need to draw the segment in, so let's turn the segment off by selecting it with segment M So let's turn the segment off, let's turn that bisector, let's get rid of it. So I'll delete that perpendicular bisector, and we could have a perpendicular bisector by selecting 2 points. So click on that one, it's highlighted now, there's my 2 points. And as I change where my cursor is, look, so my line is wandering about because it's trying to predict where I'm going to click. But if I click on I, perpendicular bisector of my chord, or of these 2 points H and I, which are an arc of the circle, passes through the center of the circle. Awesome. All right, so I'll let you play around with lots of those things if you want. One other thing I just thought of, if I have a point which is the intersection of this straight line through D to the other side of the circle, so the other end of the diameter D, and I join D, J and I up to make a polygon. I don't know what kind of polygon it's going to be, except, well, I do know it's a triangle. What do we know about the angle I? So let's see how big the angle is. Can you predict what it's going to be? So if I choose that line and this one, oh, it's 90, and as I move my point around the circle, it always stays at 90. Isn't that good? And even if it's over in the other semicircle. So the angle in the semicircle is a right angle. Oh look, demonstrated loads of things. Isn't that fun? Why don't you have a go? Make a circle, put some points on, play with it, and get comfy with it.